We're going to do a little experiment here to measure the amount of energy that a food item, a walnut, contains. And we're going to do that by lighting it and letting it react with oxygen to undergo combustion, and capturing as much of the energy as possible by heating water with that energy. Now there's some things we need to measure ahead of time so we can get numbers out of this experiment. Think a little bit about what those might be. You're right. One of them is we should know the mass of the walnut before, and we'll subtract the mass after the experiment is over to get the net change. And another thing we need to know is the temperature of the water and the amount of water. We're using 200 milliliters of water, and the temperature of the water at the start of the experiment is 21 degrees. Okay. 200 milliliters or 200 grams of water, 21 degrees centigrade. Now we're going to light the walnut on both sides to make sure it burns completely. And we're going to put this little can around it. You can see that the pencils are there for a purpose to make sure air can enter underneath and keep the combustion going. Now we're going to set the water on top so it can trap the heat, and we will get quite a bit of smoke, and the smoke means that some of the carbon won't completely burn to CO2, so we have to take that into account if we don't get as high a number for quite a bit of smoke and quite a bit of heat. Temperature's already up to 26. Of course, the can also gets hot, so some heat is wasted in terms of not being captured in the water. Temperature is now almost 30. Keep stirring the water here to distribute the heat. You can see quite a bit of smoke coming out, which means that not all of the carbon's combusting. If it was combusting, it would be CO2. You wouldn't see anything. It would not be any color. Temperature is almost 35 now. Remember, that's 200 grams of water. Our walnut only weighs about 4 grams. We'll find out how much. You can see it's still burning. You can see the reflected fire underneath. Temperature now is almost 45. This is centigrade, of course. Degrees centigrade. Remember, every degree Fahrenheit corresponds to 1.8 degrees centigrade. So that's quite a change already. Still burning. You can see the flames reflected underneath. Again, flames also indicate incomplete combustion. When you get really good combustion, like in a Bunsen burner, you don't see very much flame at all. So we aren't even getting the total heat, but we're already up to 50 degrees. 200 milliliters of water has already gone from 21 degrees centigrade to 50 degrees centigrade. That's a 30 degrees centigrade change. Seems to be burning pretty strong from the reflected light underneath the can. I've got the hoods turned on so that this hopefully won't disturb our neighbors, because it's producing quite a bit of smoke. Maybe I should have done this in the hood. Almost 60 degrees. Originally I was going to put 100 milliliters of water. I'm glad I put 200. Because I would be boiling already if it was only 100 milliliters of water. Still a bit of fire underneath, still burning. Temperature is now 62 centigrade. We've gone up 40 degrees centigrade. That's over 70 degrees Fahrenheit, change in temperature. The fire is diminishing. It looks like it's almost over. So you can take a peek inside. A lot of black soot on the bottom of the beaker. Temperature now is up to 64, 63 and a half. Let's say 63, let's mix it a little bit. Another thing we could have done is put some aluminum foil to keep the water from evaporating to trap more of the heat. Final temperature looks like it's about 64. I'm definitely not going to touch the can. The can is a lot hotter, I imagine, being metal.